Here we have chapter 12, which is all about Saturn. Let me use this scroll. This picture of Saturn is, of course, in false color, which just means we enhanced, computer enhanced some of the coloring just to look at some of the contrast. Anyhow, of course, Saturn is most famous for its ring system. The ring system is actually very, very thin. It follows the equator of Saturn. It goes around the equator of Saturn and tilts with Saturn, of course. It's made mostly of ice, basically kind of like snowballs, little very, very tiny snowballs. Some smaller than a few millimeters. Several tens of meters in size. All right, so these are some of the things we're going to talk about. Of course, it has Saturn is a gas giant, so just like Jupiter, it doesn't have a surface. It just has gas that gets thicker and thicker and thicker as you get closer to the center. It does have a magnetic field, although much weaker than that of Jupiter. And of course, we'll talk about the rings. The moons of Saturn that are particularly interesting to us. All right, so let's start with the basic properties of Saturn. So there's its mass, 5.7 times 10 to the 26th kilograms, and of course it's much less massive than Jupiter. There's its size, and notice its density, kind of interesting, would be in grams per cubic centimeter, would be 0.7 grams per cubic centimeter, and so it would actually be less dense than that of liquid water. So, that's just an interesting fact. It just like Jupiter, of course, it rotates. Different parts of it rotate at different speeds. It rotates fast enough that it's the north and south poles of Saturn are actually pretty flattened. All right, and let's see. So here's some nice pictures. As Saturn, of course, orbits, it goes around in its orbit around the sun. We see the rings at different angles, which makes sense because the tilt is always pointing in the same direction. So as it goes around the sun, we'll see. Sometimes we actually see the rings edge on, and it's actually really hard to see the rings through a telescope. If you notice, take a look at the rings right about here. There's a pretty large gap between the rings, and that was actually first noticed by a guy named Cassini several hundred years ago, and that's actually called the Cassini gap, or the Cassini division, it's also called that. Now Saturn its atmosphere does show bands, zones and bands. Not nearly as prominent as those on Jupiter. The colors are much. They tend to blend in with the color of Saturn. Of course, just like Jupiter, it's made up of molecular hydrogen, also helium, methane, and ammonia, although it has significantly less helium, and that's actually turns out to be very important for how Saturn gives off more heat energy than it receives from the sun. We'll talk about that in just a few minutes. All right, so there's another picture, a very beautiful picture of Saturn. It's usually one of the favorite planets, when people look through telescopes, they love to be able to see. If Saturn is visible, that's one of the fun things to show people, because it's pretty easy to see the rings. Even with a relatively small telescope, you can see the rings. This is actually some exceptional. This is an exceptional view of the rings. You can really clearly see the Cassini gap, or the Cassini division, as it's called, as well. All right, moving right along here. Let's see. So the atmosphere. The pressure is lower, of course, because it's certainly it's not as dense. It's not as massive a planet as Jupiter. It does have three specific cloud layers. They're shown over here. They are thicker. The cloud layers themselves are thicker. All right. That's not all we have to say about that. Let's see. This is actually shown in what's called false color to show that we can see the zones and the bands on and even some little tiny storms on the surface. Sorry, not the surface, the outer atmosphere of Saturn. But of course, this is shown in what's called false color, where that allows us to emphasize differences in the surface, or I keep saying surface, sorry, in the outer atmosphere of Saturn, which of course has no surface. This shows the wind patterns. I guess I should mention this as well. Remember, Jupiter had the Galileo space mission that orbited Jupiter for many years. Saturn had a mission called Cassini. The spacecraft itself was called Cassini, and it orbited Saturn for many years as well. And actually, not too long ago, the mission control actually crashed crashed the Cassini spacecraft into Saturn. And that was for the same reason that the Galileo mission was crashed into Jupiter. It was to prevent any contamination of the moons. If one or more of the moons of Saturn contained even microbial life, they did not want any kind of contamination to be taking place. All right, so that's the wind patterns. We do see some spots occasionally, but they're again very muted, and they don't last for very long. Certainly not like the Great Red Spot on Jupiter. I know I keep comparing Saturn to Jupiter, but that's a natural kind of thing. There are some storms that you see on Saturn that last a little longer than a few days. There's a nice example of one. All right. Now the interior of Saturn. From the orbiting spacecraft, Cassini. This is what we've figured out. It has, of course, molecular hydrogen underneath the very thick clouds. Well, actually, thinner clouds than on Jupiter. I got to stop talking about Jupiter. Anyhow, underneath it, we believe that there's metallic hydrogen, whereas, of course, the hydrogen is squeezed so tightly just due to the sheer volume, the sheer mass of Saturn that the molecules will get squeezed into a metallic type. All right, moving right along. Again, Saturn radiates more energy than it gets from the sun, but unlike Jupiter, which we can explain the fact that it's generating more energy because it's still in the process of cooling. Jupiter is. Saturn is not has already cooled off, and so since the origin of the solar system, so there's got to be some other mechanism, and this is the mechanism that seems most likely, with all the evidence that we have, is that the helium is not mixed up very well. Now, helium, by the way, is what's called a noble gas. If you ever had chemistry before, it doesn't tend to mix with the other elements. So anyhow, what we think is happening with Saturn is that helium condenses, just like happens in for water vapor, for example, in the atmosphere of the Earth. That, of course, would be rain, but these would be helium rain droplets in the interior of Saturn, and when that happens, the helium will actually it'll actually release heat, and yeah, so. Saturn does have a magnetic field. Again, it's much less strong. It's much smaller and not as strong as Jupiter's. We do see some aurora, just like on the Earth, where charged particles crash into the upper atmosphere of Saturn, and they glow. They illuminate because of heat, because of friction. So there's some nice pictures of the aurora, both in the north and the south, the north and south poles. All right, so let's get into the ring system. These are some very old drawings. Galileo actually wasn't exactly sure what he was looking at when he originally saw the. He drew some pictures by hand of the rings, but they look more like this first picture. He wasn't really sure. He thought maybe they were moons. It took better telescopes than Galileo had to be able to distinguish it, more like what we see right there in B and C, in pictures B and C. This is an extraordinary picture taken close up with the Cassini spacecraft. It's of course showing the Cassini division that can be seen from Earth, but then we're seeing some other things. The rings have names. They're kind of mostly it's just the A ring, the B ring, the C ring. Some of them have some other names as well. All right. Actually, the rings are all named with letters. The Enkel gap is right here. This was much more recently discovered. Like I said, you can't really see that very well from Earth. All right. Let's see. So this is, I mentioned this earlier. The size of these ring particles are anywhere from millimeter size, so it's really tiny, to several meters to tens of meters. So nothing in the hundreds of meters size, and they all occupy a very narrow plane, and the material itself is very similar to that of snowballs. And why are these rings here? I mean, what's the cause of the rings? People have been thinking about that for a very long time. And there was actually a guy named Roche who first figured this out, and basically what would happen if there was a moon, or a large body, larger than just a few meters, it would just break apart due to tidal forces if it was close enough to its host planet. All right, I'll take this up in the next.